Hello, ladies and gentlemen, and welcome back. We're looking now at question number 17 on the 2008 Pascal paper. The surface area of a large cube is 5,400 centimeters squared. Okay, so as soon as I read that, I'm going to stop for a moment and not read the rest of the question. I see surface area of a large cube. I ask, is this enough information to learn something else about the cube? Can we figure out surface area of a cube and maybe relate that to volume or side length or something like that? Other things we might think about, the number 5,400. I notice it's 54 times 100. Maybe I can do something with that, factor it out. But just, something like that. And that's immediately what pops into my mind. Okay, so let's continue reading. The cube is cut into a number of smaller cubes. Each smaller cube has a volume of 216 centimeters cubed. Now, as soon as I see that, I see a lot of cubes. I've seen a lot of cubes. I know each smaller cube is going to have side length 6 centimeters. Whether or not this is important, but I can relate the volume of these smaller cubes to their side length and probably their surface area if I need to, but we start making those connections. What formulas do I know about cubes? What information do I need to talk about surface area? That sort of stuff. All right, how many smaller cubes are there? So we've got these identical smaller cubes. I know their volume. I don't think I'm actually going to need the side length that I have calculated. If I do, I'll remember how I get that, but I think if we could figure out the volume of the larger cube and divide that by the volume of our smaller cube, that'll tell me how many smaller cubes I have. This wouldn't work with, say, surface area. Figure out the surface area of the larger cube, divide it by surface area of the smaller cube. That wouldn't work out. But the volumes, because we're basically physically chopping up the three-dimensional cubes into other three-dimensional sort of packets, we're chopping up the volume. Okay. So for this question, as I've sort of hinted at, I think we need to understand how we get volume and surface area on a cube. So a cube it's a rectangular prism, and we all have this. All sides have the same length. So the volume is going to be the side length cubed. So if I knew side length, I can get volume. If I know volume, I can cube root it, like I did with 216 in my head, and get the side length 6. All right, now surface area. Each side is an x by x square. And how many sides are there on a cube? There are 6. So surface area is 6 copies of x squared. Okay. So I know the volume of the small cubes. I know the surface area of the large cube is 5,400. That should be 6 times the side length of the large cube. We'll call that x, perhaps. Divide by 6 on both sides, you're going to get 900 is x squared. Square rooting, and if you need your calculator, go ahead. Although I do recommend your squares up to 30 to 31 squared. Just being able to recognize those can often simplify calculations. So the big cube has side length 30. Okay, so I'm going to take that and I'm going to get the volume of the big cube is 30 cubed, which is 27 followed by 3 zeros. Again, if you need your calculator, go for it, but maybe you don't. So the number of small cubes is just going to be the total volume of the big cube divided by how much volume is in each smaller cube. We divide them up into groups of 216, so we can get out our calculator and calculate this out. You're going to get I think 125 smaller cubes. I'll just very quickly grab my calculator. And 27,000 divided by 216. Yeah, 125, I was right. How did I do that in my head? Well, the top here is really 30 cubed. The bottom here is really 6 cubed, if I recognize that, which I did earlier. And so as a fraction, I can change it to 30 over 6 cubed, but that's just 5 cubed, which is 125. So that's how I did that in my head so fast. But if you got a calculator, go for it. If you need to do sort of long division, you can do that as well. Okay, so 125 is right there. It's B, and that's going to be the answer we bubble in. And then we move right along to question number 18. I'll see you for that in the next video.